This clip discusses display inverters and digitizers, common components in portable devices. Let's start by taking a laptop apart just a little bit so we can see how we might access these components. Now, a fairly typical way of removing the display panel is to unsnap the bezel that holds the panel in place by prying it up with one's fingers and slowly working around the perimeter to undo all the snaps. Try not to bend the bezel more than necessary. Remember that laptop plastic is typically cheap and prone to cracking. Either before or after the bezel comes off, you'll also have to disconnect the cable that carries video and power signals to the display. There's typically a fairly wide connector on the motherboard, and it's often labeled descriptively, as you can see here, LCD1. Here's a Windows laptop with the bezel removed. The next step is to unscrew the fasteners holding the panel to the display assembly's outer shell. This model features 4 such screws. Be careful because once the last one is removed, the panel could flip forward more quickly than you intend. It's best to have your hand on the top edge so that you can guide the panel forward, make sure all the wires are free, thinking here about the power and signal connector, and then lift it up and out. This is a fairly typical example of how we can access the inverter and digitizer. So, what do these terms mean? Well, an inverter is simply a circuit or circuit board that converts direct current to alternating current. For example, if you have a solar electric system powering your house, you have an inverter to convert the DC coming off the solar panels into the AC that all your house appliances need. Laptop circuits run on DC, which is why the power bricks that we use to plug in or charge our laptops are also called DC adapters. The electrical power from a wall outlet is AC, and the power brick changes that to DC, typically at a much lower voltage. Inverters in laptops are typically long, skinny circuit boards that live just below the bottom edge of the LCD panel and are held in place either via screws or via sticky tape. Here's a picture of a typical inverter board. You can see the electronic components along the top and an adhesive strip on the bottom for securing the inverter to the display enclosure. The inverter board will have one set of wires coming from the power supply and another set going to the CCFL backlighting array. So, what symptoms would cause you to suspect a faulty inverter? An LCD display that's gone completely or partially dark would be one clue. If you can connect an external display to the laptop and it works fine, then that would suggest that the graphics circuit, that is the graphics processing unit or GPU, and its ancillaries, is okay, and the inverter might be faulty. I've also seen inverter boards that have just had a bad connection. A little contact cleaner can bring them back to proper operation. Even if you do have to replace an inverter, it's usually not very expensive, certainly a lot less expensive than the display panel itself. I remember taking apart a laptop in the early days of LED backlighting, and I couldn't find the inverter board, and it was driving me a little bit crazy. And then I did a little bit of research and learned that LED backlit systems don't need an inverter board because LEDs run on direct current, just like all the rest of the circuits in a laptop. That's another benefit of LED displays, one less circuit board in the computer. Touchscreen laptops also have a component called a digitizer. This is the part of the display that registers touches and touch gestures, like swiping and pinching and so forth. The way most of them work is by monitoring the capacitance of a conductive layer sitting on top of the display panel. When you touch a touchscreen with your finger, you're altering the electric field on that conductive layer because your finger is a conductor. Capacitance is an electrical quantity that measures the ability of a device to store an electrical charge. The display may use several different mechanisms to locate the change in capacitance along an XY grid and thereby pass along to the operating system where you touch the screen. Another way to implement a touchscreen is by measuring electrical resistance. Now, these types of digitizers require some pressure from a finger or a stylus, unlike capacitive displays. The advantage of resistance-based digitizers is low cost and the ability to tolerate spilled coffee. Here's one example of a laptop digitizer panel implemented as a separate and separately replaceable assembly. Obviously, it's transparent, at least mostly, so you can see the LCD panel underneath. This particular digitizer is a multi-touch display, so called for its ability to use multiple finger gestures. Not all laptops use a discrete panel for the digitizer, and it's becoming more and more common for the digitizer to be laid onto the display panel during manufacturing. And if that's the case, you're probably going to have to replace the entire panel if a problem develops with the digitizer. It isn't usually practical to try to remove and replace the digitizer layer on its own. and the part may not even be separately available for order.